As I said, I was walking down the hallway this morning minding my own business, and I talked to a student in this course, and he or she said they were concerned because they had a week off of identities and 3D word problems and all that stuff. So I'm going to do a mild review today. Friday was meant to be that. It was meant to be just you guys working on problems in class. That's what the intent was. Hope you guys were prepared and made something productive out of it. We're going to do something a little bit similar today. I want to go through one 3D word problem today, this and one identity, and then we'll go back to recapping what happened last week to make sure you're good. Okay? Okay, so this is the ambiguous case. Please note it does not say the ambiguous case on the question. It will not on your test. This will also not be written on your test. Let me rephrase. It'll be written on the front page. It'll say int b sine a is less than a is less than b on the first page, but not right with the question. Okay, so you can sort of put 2 and 2 together. Okay. So I'm going to do the test first of all. I'm going to use the Spider-Man method today, solving questions where I pass around to everybody. And then you guys can actually do it here. So I'm going to start with. All right, go ahead. Tell me to type in, please. Go ahead.
20 sine 10.
Yeah.
You get like.
Go ahead.
Like 3.472.
Okay, therefore 2 times. Okay, the reason that we spend a lot of time with ambiguous case in this course is in this course and future courses, when you're solving a triangle that's clearly obtuse, and you get an angle of 14 degrees, that should tell you something's wrong. Okay, that's what the idea behind this is. All right, Alana, let's start with the regular triangle like this. So I'm just going to draw one triangle with something like that in blue. Okay. All right, how did you label that? Go ahead.
I just did like ABC, and
okay.
Then so angle A would be 10.
Yeah.
And then across from that would be 12.
Yeah.
And then at the bottom I had 20.
Okay. I'm going to do it like this. That'll still work, okay? But just for me, I can't draw it. I'm sorry. If you have good triangle skills and you can draw it separately, that's fine. Okay, but for me, I'm a very poor drawer, so I'm going to do it like that. Okay, now you're not done yet, Elena. What's the only possible thing that I can solve here? Angle B. Okay, this is the only thing you can solve right here. All right, Marissa, how do you solve for theta here? Yeah, go ahead.
Sine C over 20.
Okay.
Equals sine 10.
Right. Okay, other Elena, go ahead, please keep going.
Bring 20 up from the sine 10 and then reverse side.
Good, and what'd you get for that, please?
1640.
Can somebody confirm that for me?
Yep.
Okay, good. All right, so this is the part where you split it apart. Now we're going to do the obtuse triangle. Okay, so the triangle, I'm going to do this one in red, because I like red. This one's going to look something like this. And this is why this is actually ambiguous here. Again, if you drew your triangle like Elena did, and it was like sideways, as long as your triangle is drawn, like rotated, that's fine. Okay, so, excuse me, Krista, go ahead.
You like actually marks for some triangles?
Yeah, you should actually, it doesn't have to be accurate, but just to see the idea of an acute and an obtuse. That's what you need to actually put on the page. Yeah?
Isn't there always an angle bigger than 20 or 90, regardless of whichever way you draw it?
Right, yes, but the idea is I just want to, I just draw the two.
Yes.
Yes.
What is a self-triangle?
Yes.
So why don't you use that?
You can do that if you want to, but I just want to stop here because this is the part that I need people to know here. Okay, so how do I get the theta on the right-hand side now? How do you get that? Go ahead. Good. So theta, I'm going to put a break here. Which is going to be 163 on 18, is that right? Can somebody confirm that? Okay, now can somebody other than Cole explain to me, please? Very good, Cole. Why he did that? Why did he do 180 minus there? ahead.
This should add up to straight line,
Good, but why though?
because math.
Yeah, good.
Like the little triangle inside of the big triangle, so the 20s line up, and then like you have it here, and then it goes over into 180.
Okay. I know what you guys are saying, but I want a different word, okay?
Okay.
Yeah, go ahead. Go ahead, yeah.
Like 18 or the 180 minus theta. 360.
Right on. So just the rule, very good. The rule that we're using here is when you're solving sine theta equals k, right? Your answers are theta and 180 minus theta. Right, and if you just take a look at what we did here, right? We solved sine inverse. Your first angle is theta, your second angle is 180 minus. And this is a big thing in our next unit we're coming up to. All right, that's why I wanted you to use that way. But you're exactly right though, right? It does make a straight line. Okay, right, but the reason that it does, and the same thing, put them all in, that's true. But the reason is, this is the fundamental reason that we're doing it though, okay? All right, Summer, what are we gonna solve for next, please? Yeah, so we'll do beta on the top triangle here. Okay, what's that gonna equal, please?
180 minus 10 minus 1632.
I can't do that in my head. Minus 2. 118, I guess, right? 0.2, either one's fine. Okay, good. Now again, going back to what Lana said, can I solve the one triangle all the way through? Go ahead, if you want to. I'm not looking at your process that you're doing, but I'm just going to do side to side, just to remind you guys that it is a parallel. That it is a parallel thing that's going on there. All right, Hannah, how do I solve for beta in this triangle, please?
180 minus 163.18
And that's for a very small number. It's very small. Okay, I'm going to go to the next page if you don't mind, but I'm not stopping it, okay, but that's my favorite part of the movie, actually.
Wow.
Have you ever seen that movie? My favorite part actually was like when they had like Ultron's brain. Ultron's brain was like
No,
this, and the other computer was like
spoilers.
this. Oh, come on. No, if you haven't seen it yet, it's like out for a month. You're not going to see it if you haven't seen it yet.
Yeah, probably.
There we go. Okay. Hurry up to the next. Austin, what are we solving for next on the blue triangle, please?
Or second.
Yeah, C, whatever. Okay. Go ahead.
X over sine 1.3.1 equals 12 over sine times.
Or 0.81.
Equals, was it 12 over sine 10? Good. All right, what'd you get for that? 119 we're round up to, is that okay? Can we confirm that? We're good? No? All right, Adrian, on the right-hand side, what do we do, please? Call that X again. And I'll use 12 over sine 10 again. Great. Nicole, what does X equal, please? Somebody help her, and then I'll start with her next one. Okay? 8.21. Can we confirm that? That's not sure. Okay. Now the reason I did side by side there, again, the idea was it's the same process, just with two different triangles. Okay. So again, as Alana said, though, you could have solved the entire blue thing, and then came back and done the entire red triangle. That's fine. Okay. There's no issue with that. Okay, but I like that better. Good. Okay, I'm going to take a little break there and go back to last week's lesson, then we'll come back to the test review.
Is that really that
No,
last week's test?
no, last week we were doing test test. So here we go. We're after example 1. Graph. All right. So that's the information you're going to be given here, is that right there. Now, if you're not doing this on graph paper, I'm going to strongly suggest that you do, okay? Or borrow some from your neighborhood, okay? Because for these graphs here, it's a good idea. Once you get them down, these are really easy, okay, right? But you need to be active the first few times you do them. Is that fair to say? Essentially, okay. Fair to say these eventually get easy, okay, right? But until you see them, it's a little bit. Now, in this class, the difference between this class and 3M, if you're in my 3M class, is I'm not going to tell you what you need to show to me. Okay, right? I'm not going to tell you amplitude, axis, and all that stuff. Okay? So I'm going to pick on you guys right now. I'm going to write it on the board so you can do it if need be. Okay? So what I'm going to do is I'm going to write everything that you need here. Okay, now hopefully, the supply teacher did it somewhat similar to the way I'm going to do it. If not, that's fine, but I want you to try and follow the way I did. Now, if you're in Mr. Probably every grade 10 teacher except for me, they make you do like 10 different versions of the same graph. Here, we're not going to do an initial version and transform it 10 different ways. This is going to be very similar to the f of x stuff we did before. So if you remember back to f of x stuff, this means like multiply your y values by 2, divide your x values by 3, subtract 30 from x, and then add 1 to y. So we're doing the very same idea as that right here. Okay. All right, we're going to ask for volunteers here today. You only get to raise your hand once. I give you a second to write all that down. And if you need to refer back to your notes, that's okay. Yes?
Yeah, I can say one.
Thank you. We're going to finish first. Okay, that's true. Okay. Okay, so we're going to ask for volunteers. I want you to tell me what everything means if you raise your hand, and also what happens. So you said the axis is going to be 1, and that's going to be, again, a vertical check. Okay, so the entire graph's going to move up 1. We'll deal with what that looks like in a sec on our graph paper. Okay. Can someone else tell me something else, please? Yeah, go ahead.
Raise shift 30 degrees to the left.
Good. Okay, so what that means is, again, instead of starting at 0 degrees, you're starting at negative 30. Can I get a third person, please? Yeah, go ahead. Very good. Now, this is the part that I'm not sure how well they explained, because I didn't really give a good description in my notes, I don't think, right? But the idea is general the period of the graph. You guys did that on Monday, right? Where you painstakingly plotted every point. You didn't do that, Matt? Tuesday. Tuesday, I'm saying, Tuesday, right? So you guys painstakingly plotted every point on your graph and got a beautiful curve, and you said, wow, that's great. Okay? If you took a look, hopefully what you saw was after 360, then it started repeating again. Right? So if you think of the way it works, it's because of the unit circle is running around the circle will be 360 degrees. As you saw from your f of x stuff, that 3 means that you're dividing everything by 3. So instead of repeating every 360 degrees, it's going to repeat every 120. So this is what the period is, it's just what the graph repeats by. All right, Julie, do you have something else you want to add to this? Right. That's going to be your vertical stretch. All right, last one is 2 more action points that cosine starts at. Go ahead. What's that, sorry? Oh, yes. Sorry, I said 3. I was going to say, what's going on? Okay, yes. 90 divided by 3. Now, I'm not sure if you got the idea of action points, but I'm going to explain what the idea of that is. Okay, we did a huge amount of, on Tuesday, we did a huge amount of points. But if you notice, every 90 degrees it either start at the middle, and then the top, and then the middle, and then the bottom. Okay, so what we want to do for this graph, instead of doing all the middle points, is just sort of do the main points.
It's not our fault that you have the classroom right next to the bathroom.
It's my fault. Okay, where does cosine start at? Yeah, go ahead. The maximum point. Okay. Now, if you're saying to yourself you don't know where cosine starts at, there are 2 ways you can do it. Number 1, you can think of the unit circle. You can say, well, cosine is x, so at 0 degrees, x equal to 1. The other thing you can do is what? They'll memorize it's 2. Okay, good. The third way is? Good. You can realize that? Yeah? Yeah? Good. Okay. Oh, ooh. You guys are thinking way too deep. I was just going to say type in 0 in your calculator and do cos to find out what the answer is. Okay, that's the other way to do it. Okay, right? So, but you're exactly right though. Yes, all these are going to be s's, right? So if you type in cos of 0, you should get an answer of 1. Which if you take a look at that painstaking graph on Tuesday, went from 1 to -1, right? And then if you type in sine of 0, you should get 0. So that's going to be the axis. All right, so here we go. I'm going to graph this up. So I didn't try. I'm having problems today. Come on. There we go. Okay, so I'm going to use my graph paper. I want you guys to do it too. One thing I'm just going to remind you here once, and never again in your life, because this is actually, I think, our second last graph of the year. Wait, really? It's sad. Our second last paper. I'm crying on that. Second last. You didn't hear, Luke, you didn't hear me. I said second last. I didn't say last. I said second last. Oh, there's lots. About 8 on the exam. Well, one of each type, right? So, right? So we're on lots of graphs. Okay, back to this here, though. What does this mean right here? I sort of glossed over that. What does that mean? Okay, can somebody say that in English? I gotta close that door. I'm sorry, I can't focus. Yeah, go ahead.
Like the data or the
Okay.
the data has to be between 0 and 4.
So when you're doing your graph, and this is the important part here, I need to see your graph starting at 0 and ending at 240. Okay, so what will happen is on your graph, people will just say, well, the period's 120, so I'm just going to go to 120. Okay, you don't go there, you'll lose marks, you'll lose a mark for it. It says to go from 0 to 240, that means to go from 0 to 240. If you want to go from -360 to 5,000, that's fine, I can live with that. As long as 0 to 240 are in there. So if you want to go 1 or 2 squares to the left, 1 or 2 squares to the right, that's okay. So I'm going to draw my graph and I'm going to show you the steps that, this is, oh. I'm going to draw my graph and we'll sort of see what happens here. I'm going to show you the steps to do it. Again, if you guys did this last week, hopefully it was not too bad for you. Please note, and I know he's not, Alex isn't here today, but if somebody can tell him to please label everything as he's doing it and to use a ruler, that would be good. If you forget on the left-hand side, the right-hand side, and right axis set of theta, that's fine, I can live with that. That won't be a problem. Okay, so what I'm going to do first is I'm going to write the number that I do things here. The first thing I'm going to do is my axis. Okay, so what the axis is going to be, it's the middle of the graph. So I'm going to start here, I'm going to go 0, 1, 2, 3, 4, 5, -1, -2, -3, -4. You probably don't need that much room. So what I want to do is I'm just going to make a little green line. Yeah, so it should be 1 point on the left. Yeah, negative 30. Oh, come on. Oh, there we go. Okay, okay, use a beautiful green line down the middle. Now, this is not an asymptote. I'm doing this by hand today. Oh, goodness. Okay, since this doesn't want to work for me here, then. Okay, so that's going to be the middle of the graph. So there will be a point on the graph on your axis eventually. That's the first thing we're going to do. The second thing I'm going to do is my amplitude. Okay, can someone again help me? Okay, what does the amplitude actually mean of 2? What does that tell me here? Go ahead. Yeah, so what that means is from your axis, you're going to go up 2 to get to the max, and down 2 to get to the min. So what's my maximum value going to be on this graph? Okay, great. Great. Okay, what's the minimum value on this graph going to be? Okay, -1. Okay. I read about bringing you guys to the paper. Or both you guys in the paper.
Probably both.
Which one of you couldn't stop smiling? Alex said, oh, that's so nice. I'm so happy. All right. Number 3. So there we have our max. We have our amplitude. We have our axis. Number 3 is going to be our action points. Okay. So what that means for us as we're graphing is that every hash mark on our page is going to be 30 degrees. Okay. So on the left-hand side, I'm going to use every square here. So I got to make sure I get to. It just says to go to 240, so that's all I'm going to go. Shall we draw that? And let's spread that out a little bit more. All I have to do is get to 240, but that's what you're aiming for, so it'll be negative 30 there. Okay. Good. Number 4 thing I'm going to do is my phase shift. Okay. So what this is, that is where the graph is actually going to start. Okay, so instead of starting at 0 degrees, that's going to be the starting point of my graph. Okay, so cos of theta will start at 0 degrees, but cos of 2 cos 3 theta plus 30 plus 1 will start at negative 30. If you notice, what do I not use here? What information have I not used yet? Period. We don't care about the period. We rephrase. You do when you have to make an equation, and that's what our teacher said you guys had some difficulty with on the make an equation day. But you'll use that for that, but you don't need it to actual graph. Are we feeling somewhat okay with what I just did here? This is similar to the way she did it, hopefully on whatever that was, Thursday, Wednesday? It wouldn't hurt, probably. It wouldn't hurt. All right, so what I'm going to do is we got to get a starting point on that, go ahead. Yes.
On the left-hand side, we need the dots or for the
No.
right-hand side?
I'd recommend, you're not going to lose marks, as long as it's correct, I can live with it, okay? But it's just good form to see it like that, okay?
And then do we need the dotted lines for max and min?
I'd recommend that you do. You don't need them, but I would strongly recommend that you do. How's that? Okay. All right, where's my first point going to be on the graph? This is the starting point here. This is the key to this question. Yeah, go ahead. 3 and what? What's the x value going to be? Or the theta. What's the theta value going to be? Negative 30. Okay, so instead of starting at 0 here, our first point I'm going to do is is going to be negative 30.
Why?
Okay, now the question was why, okay? So because the regular graph starts at 0, but there was a shift of 30 degrees to the left. So it's shifted 30 degrees to the left, so that's where it's going to start at. Okay, so let's get a brave volunteer. I need about 10 brave volunteers. Where's the next point going to be? 0, 1, good. Where's the next point after that going to be, please? Somebody else? Go ahead. Good, 30 and negative 1. Where's the next point after that going to be, please? Go ahead. 16, 1. Where's the next point after that going to be? Go along, please. Quinn, go. 9 3. What's the next point going to be, please? Go ahead. Owen, what's next?
150 negative.
Good. I have 3 more points. Please, 3 new people, be brave. These are the 3 easiest questions you're ever going to get. Chris, go. 181, good. Good.
10 and 3.
210 and 3. And 240 and 1. Now here's the nice thing about these graphs, and this is why I spend so much time on the setup. Once you get it all set up properly, then just connect the dots and you're done, okay? But you got to get the setup going here on that. Was this sort of similar to how she did it this week? I hope so, because I laid it out similar to that. Yes?
Does it have to look all curvy like?
Yes, it does. Now, okay, good point. This is incorrect. That is incorrect. You will lose a mark. I'm going to erase that right now. That's much I don't like it. Okay? This is what you should be saying. You're at the beach. Look at the waves. Oh, look at that. Oh, nice wave. Isn't that beautiful? Oh,
Wait, so you can draw curves and you can't draw a triangle?
yes. It's true. Isn't that beautiful? Now, the other thing that you're going to need is this is a periodic graph. Like we skipped over the lesson where we left the periodic part. A periodic graph means it repeats forever. Okay, so this graph would actually keep on going forever and ever and ever. And if you don't believe me, type in sine of 10,000 into your calculator, you will actually get an answer. Okay, right? So these will keep on going forever. Yes. Yes, I didn't ask you to, but yes, I will ask you now, okay? Thank you for reminding me, okay, too well. What's the domain of this periodic graph? It's going to be what? How far does theta go from? Forever, okay? Now, and if you notice, that's pretty much how every single graph we've done this entire year goes. Okay, x is anything, okay, and that's sort of how it works. Now, if you could almost, now if you wanted to be mean and say, I just want from 0 to 240, I would take it in this case, okay, because that's what I told you to graph, but really it does these two go on forever. Can someone else give me the y values, please? Yeah, go ahead.
X or y is equal to anything bigger than negative smaller than 3.
Right. Equals to smaller than or equal to and bigger than or equal to, right, because it does actually hit both points. Okay, good? Yes.
What if we put x's instead of?
That's fine. I won't be, if you forget for next, that's fine. I can live with that. Okay, for these ones, but generally, because angles are theta, so we generally try and do that, okay? You're gonna have to,
X-axis.
right, but you can, go with me, you can change it, so you call the axis what you want, right? Like, when you get to calculus, this is actually the z-axis, and the x-axis comes in this way. Okay, so I don't know why it bothers the students.
Why? You know that.
All right. Okay, does this come back to most people? Someone, yes? Okay. Are they good? Okay, let's move on to a 3D word problem.